morning. Yours truly, Professor Dr. Dolphy Gilpin here, and we have returned with the continuation of the amazing 5x12 matrix, 15x12 matrix, and the sunflower matrix, the 27x12 matrix. And we first introduced the nucleus matrix, which is the Amz5x12 matrix, and we're going to now continue with the 15x12. We're here at the Quality Institute in Quebec, the province of Quebec in Canada, and 1010 Herron Road, Dorcal. And a correction to our first introduction, is not 7 miles, but 7 minutes away from the airport. About 7 minutes. You could calculate that in miles. So here we are, and we're going to extend this matrix here now to 15x12. So we have now O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, we don't want to spoil up our thing here, but it seems as if we have N twice here. So what I'm going to do, I'm going to turn this N into a, let's see, an N prime. We don't want to make a mess with the ink, right? I knew because usually when it reached here, I would have to start introducing a new thing. So I was surprised when everything came out smoothly down the bottom here, X, Y, Z. So I knew that something was redundant up here, which is the N, M, N, and so I call it N prime. For this now, we're gonna use the same thing and A, 1, 1, A, 1, 2, A, 1, 3, A, 1, 4, A, 1, 5, A, 1, 6, A, 1, 7, A, 1, 8. We just use a different representation here, going down. We keep all the A's, but we use different subscript. First row, first column, first row. Starting off with this. Actually, if we are counting from here, it would be the 7th one. 1, 2, 3, 4, 5, 6. It would be the 6th row. And this would be the first column. So this would be A16 here. A17, A18, and going on. But we're using just a different thing starting from here. Or what we could have done, or what I'll do is A prime, B prime, C prime, D prime, E prime, F prime, G prime, H prime. And this would be X. So, and for here we'll have now A double prime, B double prime, C double prime, D double prime, E double prime, F double prime, G double prime, H double prime, and we'll have V. And for here we could have I double prime, J, or since we're starting off, we could call it prime, 1 prime. I prime, J prime, K prime, L prime, M prime, N prime, O prime, P prime. And this will be U. This this will be y. So I've reached up to 10 now. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And so for the 10th, you say this is x prime, y prime, z prime. So we start off from A again. A prime, B prime, C prime, D prime, E prime, F prime. And what we're trying to do is not to make any of the parameters redundant. That's what we're trying to do, but sometimes I do this, it just takes a different appearance altogether. And since I'm doing this from my head, this is what has come. So we are trying to maintain the individuality and uniqueness in not redundant in any of the parameters, be it in the uppercase or dominant or the lowercase recessive. D, E, F. So we have now G prime, H prime, I prime, J prime, K prime, L prime. This is with it. So we have M prime, N prime, O prime. So here I have now 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we have up to the representation of the 15 by 12 matrix here. And so what we could do, we have I, J, K, L, M, N, Q prime, R prime, S prime, T prime, U prime, V prime, double prime, X prime, and this one would be Y prime over here. If you come down here, we have now Y prime recessive, Z prime recessive, alpha prime, beta prime, gamma prime, comica delta prime, epsilon prime, and theta prime. And this would be E prime. And so as we come in further here, we'll have omega prime, delta prime, del prime, rho prime. This is more like rho, and this is more like zeta. Okay, rho prime, pi prime. Pi here is a unknown parameter, and not really, we've used to represent pi by 22/7 or 3.1414, which is the magnitude constant for pi in calculating various dimensions of a circle. But here is an unknown parameter. All right, so pi prime, mu prime, zeta prime, and sigma prime. And here we have E prime. And so we come back down to here. This was when I was going off. I was going to do this in terms of rows and columns, but I changed my mind and do it by the primes. So I want to complicate things and call that that. So I just let that be a unique row. So we have A now, double prime, B double prime, C double prime, D double prime, E double prime, F double prime, G double prime, H double prime, and H prime. So we'll have some double prime here already. So this would have made a redundant row. We'll turn them into triple primes. because we already had a double prime here, and we don't want anything to be redundant, repetitive here. And of course, all this prime mean is that we're going to be exercising some first order differentiation and some second order differentiation and some third order differentiation via the prime. And the prime can also represent dy by dx, you know, in differentiation, but it also can be represented by the primes. So we're going to exercise some differentiation, and so the primes are significant in that respect. All right, so here we come down, so we have no redundant representation here. And so we come back down here, so we could use to do it, so we're doing this. I double prime, J double prime, K double prime, L double prime, M double prime, N double prime, O double prime, P double prime, dominant K prime. So as we complete now the 15 by 12, we have here, this will be N prime dominant over here, and we could introduce our unknown parameters here. And these will be numbers in the economic application here. And really in getting the frictionless infinity output in zeros. So these will be numericals in the economics application. And in the engineering analysis, it will be represented of parameters like inductance and capacitance, resistance, current, and voltages. But all those will be shown in because it's this multi-field application in engineering, science, and economics. So let's just complete the 50 by 12 here, and we have I double prime, Q double prime, R double prime, S double prime, T double prime, U double prime, V double prime, W double prime, and X double prime. So this completes the 15 by 12 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. All right, so we'll take a break here, and we'll return to complete the 27 by 12, which is up to now the sunflower matrix. And like I said, we will see why we are given these names to the matrix. 15 by 12, of course, is a Richard matrix, but I've extended to the Richardson matrix. Richardson matrix. Okay. All right, but the sunflower 15 by 27, 27 by 12, it remains constant there.